Hey there, Miss W doing another set of problems for 45, 45, 90 triangles. So let's jump right into it. So again, I have my base triangle right here in blue to give me the base of what I need to go to. So I'm going to identify my parts on my triangle. So I know that this is my x rad 2, this is my x, and then this side is also my x. So looking at what the triangle gives me, I know that they give me x. Well, x, 8 radical 5 over 5. And if I need to find my hypotenuse, what do I multiply by? Well, x rad 2. So x rad 2. If this is x, I'm going to replace this into my x. So x becomes 8 radical 5 over 5. And I'm going to multiply by that by my rad 2. Now, remember that this is really 2 over 1, rad 2 over 1. Anything by itself, you can make a fraction by putting it over 1. So let's go ahead and multiply straight across and see what we get. So remember, there's a 1 here if I don't see it. So 8 times 1 is 8. I can only multiply inside radicands together if their indexes are the same. So 5 times 2 is rad 10. And then I multiply straight across on the bottom. 5 times 1 is 5. So looking at that example there, can 8 divided by 5 be simplified in an even manner? Will 5 go into 8 evenly, or can it reduce? The answer is no. So I check my 10. Is 10 in simplest form? Is there a perfect square, 4, 9, 16 that go into 10? The answer is no. So your m over here is 8 radical 10 over 5. Your n is the same as this side. So this is your 8 radical 5 over 5. Not too shabby, right? I don't think so. All right, so moving right along as usual. Let's go on to number 6. So I showed you that so you didn't freak out if you had a fraction. It's okay. Do the math. When you do your Delta Math assignment, you may see some of that when you're working it on paper, you need to do that. And again, I'm here for you. I can't tell you that. Well, I tell you that over and over again, but I want you to understand that it's true. All right, so I'm going to move my base triangle to look like my example problem and move that over and cover that part. All right, so what I know, this is my x radical 2, so I'm just going to put a rad 2 there. And I know that this side is my x, it's up here. So I'm just going to change the value of that for x for our purposes. And I also know that this is congruent to the other x, so x has to be that as well. So x equals 2 radical 6. This x equals 2 radical 6, so this x has to equal 2 radical 6. So now I know that x equals 2 radical 6. So I'm using this formula here, x radical 2, to figure out what my answer is right here. Right here, right here. Let me make it a big arrow. There. Anyway, got carried away, sorry. So x radical 2, so I'm going to replace the x with my 2 radical 6 because that's what x is. Multiply it by the given rad 2. And let's see what we have. Outside numbers, if I don't see it, there's a 1 here. So 2 times 1 is 2. Inside the radical, they have the same index, so 6 times 2 is 12. All right, so there is no denominator, so I'm looking at this, but I need to say, hopefully, oh, I need to check and see if there's a perfect square that will go into 12. Remember perfect squares. 2 times 2 is 4 is a perfect square. 3 squared, 9 is a perfect square. So on and so forth. 16 is a perfect square. These are your perfect squares. You're seeing if this will factor to one of those numbers. And you will see that 4 goes into 12. So I'm going to do the square root of 4 times the square root of 3. If I multiply those together, I get the square root of 12. And I'm keeping my 2 outside for right now. And what is the square root of 4? That's why we reduced it, so we could get something outside of your rad. Well, that is just the number 2, not rad 2, just the number 2. So now I have 2 outside numbers. What do you do with those? Hopefully you remember, and you said multiply. So 2 times 2 is 4, and then I'm going to bring that radical 3 over. So we did all that, which really wasn't that many steps. I just looks funny when I scribble because I don't have neat handwriting. So your answer for x here is 4 radical 3. That's it. See how what you learned in the past is all coming together? It all squishes together. So see how smart you are? Did you know you were that smart? All right, I did. Okay, so let's look at this example. Let me bring my base triangle down again. Okay, let me change my base to make it look, I don't know if I can flip this or not. I don't think I can, so I'm just going to mark my triangle what I know. I know that across from my right angle is going to be my x rad 2, so this is going to be x rad 2. I also know that the 2 legs are congruent, so this I'm just going to label x, and this has to equal x. So let's begin solving. If this is the value for x and this is the same, then this has to be rad 10 over 10. So I'm done with the side. Now, all I'm going to do is write x rad 2, because that's what my hypotenuse is. Our value of x is rad 10 over 10, so I'm going to replace this x right here with rad 10 over 10. And then I'm going to bring down my multiply rad 2. All right, looking at that, now I've got a fraction here. So if I wanted to make radical 2 a fraction, I could just write it like this. I could say radical 2 over 1. Now we can multiply straight across. 10 times 2 is 20, so we have rad 20. 10 times 1 is 10. And then you're saying, oh, now I got to check and see if this radicand can be simplified. Is there a perfect square, 4, 9, 16, on and on and on, that will go into 20 evenly? And you said, yes, Miss Wetherell, 4 will go into 20 evenly. So 4 times 5 is 20. So what is the square root of 4? 2. The only outside number here I have is 1. So I'm left on the numerator 2 radical 5 over 10. I just brought my denominator down. So looking at that answer, look at your fraction. And if you have Desmos, you can put it in there, your graphing calculator, reduce it. Otherwise, you should know that they will both simplify by 2. So if I took the fraction 2/10, I could divide the top and the bottom by 2. And I would get 1 over 5. So this simplifies more to 1 radical 5 over 5. Now remember, I don't need that 1 right there. Didn't mean to erase it all, but I had a big eraser. So this would equal radical 5 over 5, because 2/10 reduces to 1/5. So this is a 1 and this is a 5. Okay, don't freak out. You can do it. I believe in you. You guys are smarter than you give yourselves credit for. I know some of you are like, this is too hard. It's not too hard. It just takes time. Don't you just love math? I love math. Anyway, moving on again to number 9. Okay, so I'm doing, again, harder ones with you so you can get the idea and you can do them on your own. This is this week's lesson only, so there's no excuse for you not to spend time in this lesson only. All right, so looking at the next problem here, again, I'm going to start with identifying my sides. I know across from the right angle is going to be my x, and I'm going to just change these values to x radical 2. I know that both of my legs on my triangle are the same, so this has to equal x, and this has to equal x. Okay, there's another scary fraction. It's really not scary, but it looks scary. And now I'm going to figure out, well, if this side here is 7 rad 2 over 2, then this side over here because it's the same thing, is 7 rad 2 over 2. So now I'm going to take my value of x, which we just said is 7 rad 2 over 2. So 7 rad 2 over 2, and I'm going to multiply it by the square root of 2. Can already see that this is a fraction, so I know I'm going to multiply it by the square root of 2 over 1, which is actually the same thing as square root of 2. So let's multiply. Going straight across. So there's an outside number 1 here, so I get 7, the square root of 2 times the square root of 2 is the square root of 4, which reduces to 2. And I'll come back to that. Let me do the denominator. 2 times 1 is 2. Now you can do it two ways. You can see this problem here, cancel out your 2's and get your answer 7. Or you could do 7 radical 2 over 2. 7 times 2 is 14 over 2. 14 divided by 2 is 7, whichever way makes more sense to you. So with all of that work, we found that this answer here is just 7. So you have that done. Again, take your time, take your steps. If you're not getting the answers right, email me, take a snapshot of your picture or your picture of your work. Email me and I can look at it and try to figure out what's going on. I am here to help. All right, moving on. Is that it? Oh, that's it. Aren't you lucky? All right, you guys can do this. I believe in you, so I will see you.